Okay, so now we're going to look at solving problems using a z-score calculation. So here's an example. So the mean score on the test was 70 with a standard deviation of 5. 60 students wrote the test. So how many students scored between 72 and 83? So just in terms of my normal distribution, what I've got is my mean, and then my axis is labeled here. So I've got a 72, which is around there, and my 83, which is around there, right? So what I'm really looking for is how many students are in this area right here. Right, so in this orange area. Okay. So first of all, what we need to realize is that when I do z-score calculations, and I look the number up in the appendix in the back of the book, that number tells me what percentage of the students that wrote the test scored less than that score. So if I look up a z-score for, I don't know, negative 0.5 right here, that number that they tell me would be the area to the left of that z-score, right? So if I find the z-score for 83, that number that's in the table would tell me the area less than 83. It wouldn't just give me this area here, it would give me this area as well as all of this. So strategically what we'll do is we'll find the z-score for 83. That will tell us all of that area below 83, so all of this here. And then what I don't want is this blue area right here, right? So all I have to do is take that out. So to do that, well, that's actually just what's below 72, isn't it? So what I can do is find the z-score for 83, find the z-score for 72. Then once I know what area this is, I take it away from this area right here to give me that missing area there. Okay, so now let's execute that strategy. So my first step would be to find the z-scores for 72 and 83. So my z calculation is x minus mu over sigma. So let's first find the z-score for 72. So that would be 72 minus 70 over 5. Okay, 72 minus 70 is 2 over 5. So 2 over 5 is 0.40. Write it as 2 decimal places because that's how many decimal places are in the z-score table. Then I find the z-score for 83, so that would be the same process. So it would be 83 minus 70 over 5. So that's going to be 83 minus 70 is 13 over 5. So that's going to be 5, 10, 2.60. Okay? I hope that z-score table goes far enough. Does it? Just checking. It does. Okay, good. So, now what I'm going to do is go to the z-score table and find out the areas below each of these z-scores. So, opening to page 581 now. Now, my z-scores are both positive here. They don't always have to be positive, but they are in this case. So since they're positive, I'm going to be looking on the page 581 section. My first z-score was 0.40. So I find 0.4 right here, and then the 0 is just right here. So it's 0.6554. So that tells me that 65.54% of the data are to the left of the z-score of 0.40. So 65.54%. Alright. So I'm going to write down 65.54%. Okay? Now I'll find 2.60 in the table. So same process here. So 2.6 and then 0 is right here. So 0.9953, so that would be 99.53%. So 99.53%. So what these numbers tell me is that below 83 are 99.53% of the students that wrote the test, and below 72 are 65.54% of the students that wrote the test. So to find the percentage of the students that scored between 72 and 83, I would just take 99.53 and then subtract 65.54. This is now going to give me the percentage of students that wrote the test that scored between those two values, right? So subtracting those, that's going to be 33.99%. So that tells me that 33.99% of the students scored between 72 and 83. But the question did ask me how many students scored between 72 and 83, not what percentage. So since I know that 60 students wrote the test and 33.99% of them scored in this range, I can calculate how many students scored in that range. I would just take 33.99% of 60, right? So this would just be 0.3399 times 60. That gives us times 60. So 20.394. Of course, I can't have 0.394 of a student, so I'm going to round this to the nearest whole student. So this tells me that 20 students scored between 72 and 83.